Hello, friends, students, and enthusiasts. One more project. So this is related to grids, that is solar grids. And here, differences, we have used a Raspberry Pi Pico board, that is Raspberry Pi Pico W board, and an LCD, that is 1306. It is an OLED display. So first, name of the project. It is a self-diagnostic grid connected PV system with fault classification plus web dashboard in MicroPython language. So here, what are the components I have used that I have given? That was hardware components. What are the components? You can see these are the hardware, all hardware connections, what we have given. That is, the main is this board. That is my controller board. I have used a current sensor. I have used a DST 11 sensor, and I have used few of the resistor. This is for your voltage divider, and for current, I have used one LED over here. So what I'm trying to tell you is, and you can see this on the screen, all the live voltages, that is PV voltage, PV current, AC volts, and temperature, everything is, and it is showing finally what is the status grid, the status of grid failure. Why the reason? I will tell you a little later. The reason beginning, I will tell you the AC is less here. As you can see here, AC voltage is 144.22 volts. Okay, that's why it is showing status grid failure. What is the reason? I will tell you a little later. So as according to the faults you diagnose, this values here as well as on the OLED display will change and it will show you. That is our project. Okay, so what we have used in sensors, that is a voltage divider we have used. I told you for the timing I not used any sensor. I'm using resistor over here. Then the current sensor, you can see here in the corner, this is my current sensor, which I have only one number I have. So I have used this current sensor. You can see here, this is my current sensor. Okay, the same ACS 712, which is connected to GPIO 27. The previous voltage divider was connected to GPIO 26. AC voltage, again, please remember AC voltage, that is the voltage which is coming, that is AC voltage which is coming from the grid here. So that there also you have to isolate it and you have to connect it properly. But for the time being, I have connected it here and I have not changed the specification. Just this is a lab project. Okay, so I have not used AC in fact. Okay, so that is connected to GPIO 28. DST pin is connected to, this is my DST pin, this is my temperature sensor, this one. So this is connected to pin number 15, which is coming over here. Okay, so this is pin number 15. Okay, so LCD, I have this LCD, SCL and SDA, which are connected to GPI 0 and 1. That is, it comes here in the corner. These are GPI 0 and this is 1. Okay, so these are the connections, as you can see on your screen. What are the sensors we have used? Instead of this corner sensor, that is voltage sensor, I've used a resistor. Okay, please remember that. Okay, you can use the sensor. This is isolated. This is a small transformer and you can isolate it. Okay, now before starting the project, please remember the pin diagram of the Pico is very important. So please open the pin diagram and please keep it ready with you every time when you do a project based on this. That is using a Pico board. Okay, so that you will give the connection correctly. Because if you miss this connection, whatever the connection given on the breadboard, you can see here. Okay, so if you miss this connection, then it will be difficult. So on a breadboard, I have fixed my controller board. That is the W is my Pico board. Okay, what are the connection? You have to remember 5 volt. The power connection, as I told you, you have to be very, very careful. Okay, the power connection and everything is very, very important. So SCL, SDA, pin number 15, and the other pins, that is pin number 27, pin number 28, pin number 29, which are on this side, analog pins, which are connected to the loads and the sensor. You have to be very, very perfect with this. Okay, so you have to be very perfect with those things. Okay, right. So this is continuously changing, whatever the loads, but of course now the load is not there, so it will be moreover, it will be constant. Connections are very important. Now we'll come to the next slide where I will explain you about the system architecture. That is a block diagram, you can see. So solar panel is connected to sensors. Sensor is connected to RP Pico W, that is my controller board, which you can see it here. Then it is connected to LCD, that is the board is connected to the LCD. And the Wi-Fi web server is also there, which will show you the web dashboard, okay, which will show the web server. What are the advantages of this particular project? No cloud needed. That means we are not using any cloud, external cloud, that is internet cloud. Working on mobile phone, laptop, this you can see here that this works on mobile phone also. It is, since it is connected to my mobile phone, it works on a mobile phone as well as a laptop, ideal for lab demos. for lab purpose, lab demonstrations. This is ideal for that purpose. Okay, right. What are the features? What are the features of this particular project? The PV grid by PV, that is photovoltaic, the panels will be there, which are PV, we call it as PV plus grid, it will be monitored. Fault classification, that is it will classify into faults. Serial debugging will be there. Debug, it can be serial debugging, that is we can see the IP address and everything on the serial that I will be showing you. Wi-Fi web dashboard will be there. IP address display on serial monitor. Again, exam friendly logic. Suppose you're examiner or something, so then in that case that it will be very easy. One more thing, now you testing, when we see the testing part here, reduce PV current, partial shading. That is, if the reduced current, it will be shown, expected that the fault is due to partial shading. Disconnect AC sensor, inverter fault. Okay, inverter fault. Okay, grid failure, reduce AC voltage. As we have seen here, AC voltage is reduced, so it is showing grid failure over here. Okay, so DST temperature, over temperature and all that I will show you in the this thing. Now this is very important parameters, that is the parameters, fault diagnostic parameters, which I have given in the Python codes, which has to be taken care. That is PV voltage above 15 and PV current above less than 0.03, then it will write partial shading. Okay, and else PV voltage is more than 10 and AC is less than 80. Please remember that it is now less than 180. That is the reason it is showing this thing, like fault of the panel disconnected or grid failure. Here again it is given. Else if AC voltage is less than 170. So it is 170, less than 170. So these are the parameters what you have, which are very, very important, which are given in the codes. Okay, right. So these are this thing. Now you can name this project with this all names: real-time PV efficiency degradation tracker. Then grid disturbance impact analyzer, or PV, for PV outputs. Third is smart net metering analyzer, that we can analyze as net meter, that is energy injection or consumption we can show. Okay. Fourth is AI assisted. Please remember, since we are using machine learning, the codes which I have shown you, that we can learn it, and we will we can name it as AI assisted PV performance prediction system. Fifth is grid connected PV system with power quality index. So these are the names which are suggested for your same project. Okay, to Thorny ID, we are into codes part. So this is Thorny ID. There are two files over here. You can see here. This is the one which is going on right now. You have to give SSID password, and these are the files you'll require it. That is network import import socket, time, and EDC. That is I2C, DST, and SSD 1306. So 1306 file, I have kept it here. Please remember this. You will get it with from GitHub. You can copy and you can paste it here. Please remember, first you download this file, that is SSD 1306, name it to SSD 1306 PY. Then you just save it in your Pico board, that is on your desktop. Okay, you save it in the next is grid. The second file, that is I'm going to share with you. This is the main file that will when you press this run button, then when you press run button, you have got this IP address. The IP address, web server IP address, you got the same IP address. You can see here, I have typed it on this particular thing, and I'm getting the complete thing. You can type it on your system also, or you can do it on your any of the system. So locally we can see with the help of a display here, that is the LCD OLED display, and as well as on your mobile, both the place. So here all HTTP codes will be here. I will just show you what are the HTTP codes here. These are all HTTP codes. This green in color are the HTTP codes, and I have also given the parameters. This is the parameters I have just told you about. That is, it will check the system. That is, if it is less than 170, that is, it will tell you grid failure. So this all parameters you have given. That is faulty diagnostic parameters. We have written it here, and all simple this thing, that is ADC readings and all. You can find it out, anything you want. You can, this is the Wi-Fi, about the Wi-Fi, how the OLED display and its addresses, everything, it will be read or given in here. So DST pin is connected to 15. As other pins, I told you the other pins will be connected to other given pins that already I told you, and we are getting the readings of. So I'm going to share this with you also. This part also I'm going to share with you. So little different, that is using different type of controller IC or board. And I've added this display over here. Of course, we are using 4 or 2, or rather 3. We can use 3. That is temperature, two current sensor. One is for input, that is for the grid, and another one for AC, and some voltage divider. You can connect it to your panel side. That is when the DC is taken from the panel, there you can connect the voltage divider, and current also the same module. That is same sensor can be used for the current from the panel, calculating the current from the panel. So that will be the perfect one. I've just given you the idea how it will work. I will be sharing with you. I hope you will like it. If you like it, please write a comment. If you want something else, please do tell me. Thank you very much. Thank you for watching.